Saxon Algebra 2, it's the last day of the year. The math year, anyway. Wherever you happen to be in the calendar year, this is it. Algebra 2 is coming to an end. Remember, we kind of rejigged our study week for this last week. Remember that we've covered, let's see, we've covered 117, 118, 119, 120, 121, and 122. The last, what is it, 6 lessons? 7 lessons? 23, 24, 25, 26, 27, 28, 29. The last 7 lessons are covered better in next year's book. There are proofs that are useful to us, but the way John sets them up and to introduce them to you at this point in the year, it's too much. So we're going to save proofs. We're going to cover them next year. There are a few of those lessons in this book that relate to construction, which is using compasses and such to draw various geometric shapes. Not only is that a particularly old-fashioned and unuseful study, but today the quality of today's compasses is so bad, I don't want to put you through that frustration. So that is why we are skipping that material. It is not because I want the year to be over. If it was good material, I would say, heck yes, we're going to do it if I thought it was useful and important, but it's not, and I don't want to waste your time. So we are winding up today with lesson 121, which is a humdinger. It's a good lesson. I like it a lot. One of the things that we want to remember is that with inequalities, right, greater than or less than, when we multiply by a negative number, I'm going to write it out in English, which you know I don't really like to do, but we're going to do it and then I'll decode it for you. This is something you already know. When we're multiplying an inequality by a negative number, or dividing for that matter, but I'm not going to add more words to this, we have to flip the direction of the inequality. And let me just show you what I mean. If we have x minus x is greater than 4, and we want to clean this up, right? Because we don't want a minus sign in front of that. And we want to multiply both sides by minus 1. We can do that, but we have to flip this. So this becomes positive x. This we have to change direction. And then we multiply that side, right? So we can do it. We can multiply in an inequality by a negative number. But if we do it, we have to flip. All right? This is the rule that drives what's happening in this lesson. 121.1. Let's see, how many examples are there? There are 2. Graph, John asks us to do. 1 is less than or equal to. Okay. So what we have here is an inequality that we need to graph. Okay, we see there's just an x, there's no y, so we know it's not a Cartesian coordinate, it's just a simple number line. Domain equals the reals, fabulous, that's arrows. I like those better. I'll be honest, I'm prejudiced against those little integers and their dumb dots. Sorry, I do have very strong opinions about what I like and don't like. I try to play neutral, you know, because I don't want my students to be biased, but I've got a lot of opinions about math. I know, that's weird. Okay, anyway, go ahead. You know what? Here's the thing. I don't mind being stereotyped as a mathematician because in my earlier life, I was an accountant. Do you have any idea how many nerd stereotypes there are about accountants? Like, it's everybody's extreme example of a dry, boring, monotonous person, right? So, I mean, is that me? Come on. Stereotypes serve a purpose, but they are meant to be broken. So, if you want to stereotype me as a dry, boring mathematician, bring it on. Won't hurt my feelings at all. Anyway, where was I? We're supposed to graph this. Well, we've never seen anything like this before. It's like fraction. What the actual heck are we going to do with this fraction? And then we go, oh yeah, rational inequalities. Rational implies fraction. Whenever we see rational, we go, oh, okay, fractions are coming at us. So here they are. All right, fine. Well, in order to simplify, we've got x on the bottom, so that's just drama, right? In order to get rid of that, we know that with an equation, not an expression, but an equation, and this is kind of like an equation, we can multiply both sides by the denominator to get rid of it, right? So that's our plan A, right? Is let's multiply this x minus 4 times x minus 4, and then that will allow us to cancel. We'll have to do some simplifying, but it's fine. It'll get rid of our denominator. But whoop, 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 we have this to consider about. That was my alarm going off, by the way, that whoop, whoop, whoop. I didn't want to make too crazy a noise because Gracie's starting to get a little restless today. You know, it's WALK time, so I have to not stir her up too much. Okay, so if we multiply both sides by x minus 4, that takes care of this problem. But at this point, we don't know if x minus 4 is a positive or a negative number. It's really windy out, my wind chimes. Are clanging it up. Okay, is x minus 4 positive or negative? We don't know. That causes a problem for us because if it's negative, we can still multiply it by it, but we'd have to flip this. But if it's positive, then we wouldn't want to flip it. So how do we resolve this conundrum? And I'll tell you how. We multiply by x minus 4 twice. What? If we multiply by it twice, then we know it's positive because a square is always positive. So we're going to multiply not by 1x minus 4, but by 2x minus 4s. That will still allow us to cancel, and it guarantees us a positive number so that we don't have to worry about flipping. Isn't that a fascinating little piece of mathematical thinking? Okay, so that's the rule, is we always multiply by the square of the denominator. Let's carry on with the numbers and you'll see how it plays out. So now what I've got, this is just a 1. So on this side, I have both of the x minus 4s that we chose to multiply by. They are living on the left side. On the right side, I have minus 1 times the quantity. And one of them canceled against our denominator, but we still have 1 left over. That's just the price we have to pay for using this strategy to avoid our positive negative number drama, all right? So both of them live on the left side because we had nothing to cancel them against. One of them continues to live on the right side. So now what we have to do is we have to multiply this out, right? We want this as a trinomial. Can you do that in your head? It's x squared. The middle term is these two added together. The final term is those two multiplied together. If you need to write that out and do the dance, that's fine. But most students at the end of Algebra 2 can carry these in their heads. All right, and then over here, we just change the signs. It's minus x plus 4. Okay, whew. Now we want to bring everything to one side. So let's add x to both sides, and let's subtract 4 from both sides. We get x squared minus 7x plus 12 is less than or equal to 0. We zeroed both of those out. Okay, now we're to a place that we're familiar with because we know how to graph these inequalities. First, we try to factor this by inspection, and John is kind and benevolent. X minus 3, x minus 4 will do the job, right? Now we just switch into that graphing inequalities gear that we have developed. What was it, lesson 110 and 112? We want them to be less than 0. That means this has to be a negative number, so that means we can either do it positive, negative that way, or negative, positive that way. We now make our chart. Positive, negative, negative, positive. I like to put the first one over here, the second one over there. These little details just help me prevent little mistakes from creeping in. I still make mistakes, dumb, ridiculous mistakes. Like yesterday, wasn't it with you guys when I was distributing and I didn't multiply 8 times 10? I make mistakes, but I try to prevent them with all my little systems and organization methods. Okay, so in our first one, the first binomial is going to be positive. X minus 3 is greater than 0. Remember, once I establish these, I don't have to think about this anymore. That's taken care of. Now I'm just paying attention to these signs. And I want my second binomial to be negative, so x minus 4 is less than 0. Now in my other scenario, the first binomial is negative, and the second one is positive. All right, I solve, change sides, change signs. These should all have equals on them. Remember, we don't change it. Whatever the problem is originally using, we just keep using it all the way through. X is greater than or equal to 3. X is less than or equal to minus 4. X is less than or equal to 3. X is greater than or equal to 4. Wait a minute. No, that's right. This is positive. Right? Because these are all minuses, so these are all positives. Okay, good. I feel good about that. All right. Can a number be less than 3 and greater than 4 at the same time? No. There's no solution over here. So this is the answer to our whole thing. What's our domain? Oh, it was 100 years ago we were looking at our domain, isn't it? Our domain is the reals. Okay, so we're drawing arrows. So it's greater than or equal to 3, less than or equal to 4. That looks like our solution, but where's my piece of paper? If we look back to the very beginning of this problem, which is on a piece of paper. Oh, I know, the wind blew it away. Okay, it's on the floor somewhere. Our original problem looked like this. Right? At the very beginning, we need to put a limitation on our answer. We cannot let x minus 4 equals 0, right? Because this is the denominator. Denominators can never equal 0 or the kingdom implodes. Watch it. It's in a playlist on my YouTube channel. You cannot let the kingdom blow up. So we cannot let this denominator ever equal 0. And if we just solve this, then that means that x cannot equal 4. In the future, we're going to do this at the beginning of the problem, but I didn't want to distract us with one more thing at the beginning to confuse you. So before we settle on our final solution, we have to make sure that we're we're meeting this limitation that we imposed on ourselves way back at the beginning, x cannot equal 4. So even though this tells me that I should be including 4 in my solution, this tells me I can't. So that's why we don't color this 4 box in. We have to leave it as is. Otherwise, we're blowing up the kingdom. And I don't want responsibility for that, you guys. Well, it's already blown up, so I guess we can't really do much. But that's why we don't color in that circle. Because we have this limitation that we established way back at the beginning. And from now on, we will start doing it at the beginning. And that's why we leave that open, because we can't let 4 become a solution. One more. This is our final example for the year. And it's so satisfying. 1, 2, 1, 2. Oh, I drifted, and the sun's coming out. Okay, graph. You can expect to see one of these on the test, by the way, if you're taking a test with me. Domain equals the reals. Oh, thank you, John. The reals are the arrows. So much easier to deal with. Okay, we have the same problem at the very beginning. We see a variable in our denominator, and all our alarms and bells go off. We cannot let m plus 2 equal 0, right? We're going to limit that right from the start, and then we'll have to remember and keep it in mind when we're framing our final solution. So that means m cannot be equal to minus 2, all right? We'll just set that aside and remember it for later. Now, we want to get rid of this denominator, and we go, oh, okay, well, what you do is you multiply both sides times the denominator, then you can cancel it. But then we remember, oh yeah, the inequality causes problems because this could be a negative number, in which case we would flip it. So we can't just multiply like this because we don't know whether to flip or not. But we know that if we square this, if we multiply by 2 of these things, even if one of them is negative, 2 of them has to be positive. So now we have taken care of that denominator in our inequality in a way that is perfectly safe and guaranteed to work. So let's see, we can cancel one of these, but now we have some multiplying to do. We have to multiply these. I don't want to write it out if I don't have to. And when I look at this, I go, oh, this is a difference of 2 squares, isn't it? Okay. So that means I could write this as m squared minus 4, right? Because then you'd write it as m plus 2, m minus 2, and that's exactly what we've got. And then over here, it's going to be 2 times, let's see, I'll multiply that in my head, m squared plus, we add them to get the middle term, 4m, we multiply them to get the last term. It's kind of crowded. Now, Lord have mercy, I have to distribute that too. So we have m squared minus 4. Okay, now I'm multiplying that. Makes sense? Now, let's clean it up. Let's move these guys over here. So I'm going to subtract m squared, and I'm going to add 4. We've cleared this side. We have m squared, let's see, so I'm going to put the 0 in. M squared plus 8m plus 12. That looks good. I don't like it this way though. I want to flip it. M squared plus 8m plus 12. You don't need to flip it. Okay, now I have to be careful as I flip it. I'm not trying to change this, but as I move the 2 sides around, this has to move too. This is greater than 0, so now I write it this way. Right? I'm moving the pieces around. I'm not doing any math to this. I just need to carefully reorient it because I'm flipping the other 2 sides. Okay, so this is good. Now I can factor this. m plus 6, m plus 2, multiplies to 12, adds to 8, bingo. I want these two factors to multiply and be greater than 0, so that means they're either both positive or they're both negative. Time for a new piece of paper. Better hold on tight so the wind doesn't blow this one away too. Okay, so now that I've got my plus minus thing worked out, I can start my chart. I don't have to worry about this sign anymore. I've covered my bases with that. And so now I just want to write each binomial so it will create the right kind of product. So I'm going to go m, not x, m plus 6 is greater than 0. Oh, I need an equal sign too. We just match them. And then I want m plus 2 to also be greater than or equal to 0. I had to squish that. That doesn't look very nice. And then I want both negatives. M plus 6 to be less than or equal to 0, and m plus 2 to also be less than or equal to 0. Again, don't think about whether it's greater than or greater than and equal to, just copy. All right, now I am ready to simplify these. And one thing I do just to double check for accuracy, I scan across, I notice that I have both positives up here. So these should all be positives, yes. And then when I simplify, when I solve these, they should all come up as negatives, shouldn't they? So there's so many numbers flying around and I'm trying to do this in my head. So I just carry a few of those checkpoints to make sure I'm not making dumb mistakes. Too many dumb mistakes. Okay, great. We're good. Now we're going to graph both sides. We have minus 6 and we have minus 2. So this one goes like this, and this one goes like that. So the shared solution is right here, isn't it? And then over here we have negative 6. This one goes like that. And then we have negative 2. And it goes like that. And the shared solution starts at negative 6 and goes south. It's not really south, but pretend. So then our shared solution is like this. But I also want to remember, what was the limitation we created? M cannot equal minus 2. So I'm going to copy that down here. Since I'm on separate pages, I want to remember this because, oh look, it is going to matter right there. So I know I'm going to graph this half first. Negative 6, circle it, fill it in, go that away. That's all part of the solution. That's this. This one I have to adjust because I cannot include negative 2. So I need an open circle there because of this. And then I can go this way, picking up all those other values, right? I have to drop minus 2 out of the solution because of our original limitation that if we let x equals minus 2, we'd blow up the universe. So that is the correct answer, like this. This was our original limitation that we imposed on ourselves. As soon as we noticed the variable, as soon as we noticed this denominator with the variable in the denominator, we knew we needed a limitation. Anytime you see a letter in a denominator, you have to create, in an equation or inequality. If it's just an expression, it's fine. But we can't let that equal 0. And so we immediately set up that limitation. Sometimes John does it for us, which is cool, but we have to remember that's our responsibility too, is to take care of those variables in the denominators so we don't blow up the universe. This is the right answer. And I have one more thing that I want you to write this year. pleasure working through John Saxon's Algebra 1 with you. I hope you enjoyed it. I salute you. If you finished the book, man, I salute you. That is hard work. I hope you do some sort of testing to sum it up and to prove to the rest of the world how incredibly accomplished you are. I hope that you will join me when you next begin a course of study for John Saxon Advanced Mathematics. Another 120 lessons of pure joy. I look forward to sharing them with you. Students, if you're local and you're taking a final exam with me, we'll do our regular review problem this week. I will drop you a review video on Monday morning. I'll drop the test off to your house Wednesday around midday, and then I'll pick it up Thursday mid-afternoon. Same schedule as always. 10 problems from the most recent material, 5 points each. Hallelujah, we're almost there. Thank you. Goodbye.